Okay, so it's now the second week of summer session, and so time is I'm just gonna keep chugging along through through our material in stats. Some of you guys took the quiz this morning. Some of you will take it later today. The TAs, I've asked them to try to get them graded and return to you by next week's section. Okay, so you should see that the grades will also be posted on CCLE once they're finished grading them. Okay. Any concerns or issues with things so far in the class? Homework's going okay? Content material? Yes, question.
Okay, for box plots, do outliers count as...
Okay, so I don't want to answer any questions specific to the quiz right now because some students have not yet taken the quiz yet. Okay, so I feel like that's a quiz-related question. So I'm not going to answer that at this point. Okay. Other questions? Okay. Well, we'll get started on chapter 4 here, okay? So, okay. And so chapter 4 still fits under the topic of descriptive statistics, okay? And here we are describing the relationship between two numeric variables. Okay. So again, if we think back to the course overview, we begin with descriptive statistics. And under the topic of descriptive statistics, the idea or the big picture behind descriptive statistics is that we are trying to describe data that we have. Okay, so we have data, and so in chapter 2 we talked about kind of displaying some of that data using histograms for numeric data or dot plots for numeric data. We also looked at using bar charts for categorical data. And in chapter 3, we talked about creating numeric summaries for our numeric data. Okay, so just kind of a recap as to, lost my cursor here. So just a recap of where we've been. So under chapter 1, we said, we talked about, what is data? And we talked about gathering data and experiments and observational studies, things like that. Okay. Under chapter 2, we showed graphic displays to describe our data. And under chapter 3, we had numeric summaries or summary statistic. Or numeric data. And then so today, chapter 4, we're going to describe relationships between two numeric variables. Okay, and so this kind of encompasses all under the topic of descriptive statistics. We're just learning how to describe our data. Okay, and then starting Wednesday, we'll look into introductory probability. Okay, and we'll get into that topics of probability and then probability distributions and sampling distributions after that. Okay. All right, so we're going to describe the relationship between two numeric variables. And so imagine we have some kind of data set. Okay, and maybe what we are going to record is we're going to record someone's name, and then we're going to record two numeric variables. So we will record someone's height, and then we'll record their weight. Okay, and so these will be numeric. And so let's say, you know, we have Adam, who is 5'10", 70 inches tall, and weighs 165. Okay, and then we have Bill, who is 6 feet tall, 72 inches tall, and weighs I don't know, 170. Okay, and we'll have Cheryl. She is 64 inches tall and weighs 140. I don't know. Kim, I don't know. All right, we'll say is 62 inches tall and weighs 120 or something like this. Okay, I'm just making up stuff. Okay, and overall we want to ask, you know, is there a relationship? This is our ultimate question. Okay, is there a relationship between height and weight? Okay. And then how can we describe this relationship? How can we describe the relationship that exists in our data? Okay, and then let me just write kind of just some arrows to indicate that I've only written out numbers for 4 of our observations, but perhaps maybe we have lots of them. Okay, and so our first tool in this is the Scatterplot. Okay, and this is our graphic display. And essentially we are just creating coordinate pairs. Okay, so here I'm just marking off a number line here. Okay, so all right, and so Adam is at 70 and weighs 165, so he gets a dot somewhere like right there. Bill gets a dot, I don't know, maybe right there. Cheryl would get a dot something like right there, and Kim gets a dot down here. Okay, and we can so these are the data points that that were part of our data set, but I could just add some other dots. Okay, and we can ask a question. is there an overall relationship between height and weight? And what would you guys say? Well, we could say that in general, generally speaking, people who have high height, in general, will have high weight. And in general, people who have low height will also have low weight. Okay, so we can say general trend something like high height goes with high weight, and low height, so in general people who are short will weigh less than people who are tall. Okay? Okay, and so when we describe a relationship, there are kind of a few things we want to talk about. Okay, so describing So first we'll talk about shape, direction, trend or direction, and strength. Okay. So as far as shape goes, in this class we will we're only going to concern ourselves with those that have a linear shape. So for us, shape can be classified into a linear or nonlinear. Okay? Because we're only going to learn how to handle linear. So either we know how to handle it if it's linear, and if it's nonlinear, we're not going to learn how to handle those data sets. Okay, so linear basically means can be summarized with a straight line. Okay, nonlinear means a straight line will not work. All right, so examples of something that is linear. Linear would look something like this. So these are okay, so here's data, and we can draw a straight line that kind of summarizes our maybe that works there. Okay, and then nonlinear, if you've got data that looks like something like this, this would be nonlinear. Okay, or anything where, so now, something like, you know, I don't know. Straight line would not work, right? So if we tried to fit a straight line, it just, you can't do it, okay? Okay, so anything that, you know, not a straight line would be nonlinear. Okay, so as far as this class goes is, we're only going to learn how to handle a linear relationship, okay? And it could be, it could go up like that. We could have, you know, something like this. This is also, this is linear. It's just going, trending in this direction. That's fine. Okay. So these are both linear. Okay, because a straight line could work here. And a lot of this, a lot of times things are a little bit of a judgment call as to whether something can be described with a straight line or not, okay? We don't have, well, there are tools and statistical tests that do exist for determining what looks like a straight line and what doesn't, okay? But as far as statistical tests goes and things like that, really the best test that we have is looking at it, okay? When you look at it with your eyes, our brains just have a natural tendency to identify patterns, okay? That's why you can look at the clouds in the sky and start to see faces and shapes and things like that, okay? There's just kind of this natural tendency for us to recognize patterns. And so when we can just create a scatter plot and we have a pretty good sense of, does this kind of look like a straight line, or could a straight line be reasonable? We will have a good sense of that, okay? So the best tool to decide if something is linear or not is our eyes, okay? Okay, so create a scatter plot and look. Okay, this is how we do it. So plot the data in a scatter plot, look at that data. Does it look reasonable to be a straight line? Great. If not, then we will not be able to work with it in this class. Okay, so our class will we will only learn how to handle linear relationships. Okay. Only describe. Okay, I mean, we'll be able to describe nonlinear relationships, but as far as regression and things like that, just a linear relationship. Okay, so let's talk about direction and trend. Okay, so as far as direction and trend goes, we have a positive or negative. Okay. Positive means, so when we have two variables, right? So one variable is going to be x and one variable will be y. And so what we say is that for positive we say large values of x are associated with large values of y. Okay? And on the other hand, we have small values of x are associated with small values of y. Okay, and so overall, something like this. This would be a positive trend. Okay, so we can look at, you know, maybe age of a vehicle and miles driven. Okay, so in general, older cars will have more mileage driven on them. Okay, because so this will be low x, and this will be high X or large X. And over here we have small low y or small y and large y. Okay, so if we look down here, we will see low values of x go with low values of y, or small values of x go with small values of y. And up here we have large values of x go with large values of y. So we've got a positive trend. Okay, negative trend, just the opposite. Large values of x. So I'm just going to write large x goes with what? Small y, okay? And small x goes with large y. Okay, so over here, instead, we can say something like age of vehicle on the x-axis, and then maybe resale value. Okay, and so what we'll see a general trend where cars that get older, as they get older and older, their resale value goes down. Okay, and so over here you'll have large X, an old car, and its resale value will be low. Small y, okay? And over here we got small x and large y. So over here, you know, a car that has low age, a small age, will generally sell for more. So you know, a 2014 Honda Civic will fetch more than a 1994 Honda Civic, if that thing is still running, right? 300,000 miles on it. Actually, that would be quite impressive if there's still you know, I imagine it needed a new transmission or something put in by now. Okay, well anyway. Okay, so this would be a negative trend, okay? What if we have something like shoe size and SAT score? Okay, what will we see here? Okay, so we'll see people with small shoes getting high and low SAT scores. Okay, and then we'll see people with medium-sized shoes getting high and low SAT scores. And we'll see people with large shoes getting high and low SAT scores. So what would we say? Positive or negative or what? Yeah, so here this is neither positive nor negative, right? In that large or small shoes are not associated with large or small SAT scores, okay? And so here we would see basically neither positive nor negative, and we would see something like this, kind of this flat. Okay, so, you know, large shoes do not go. Okay, same with small shoes. Same thing. Okay, so that is recognizing trend. Okay, and we'll say that is either positive or negative, or in this case, neither. Okay, we also have okay, we have strength of a relationship. Okay, and the idea behind strength is, you know, is there lots of scatter or is there not a whole lot of scatter? Okay, so lots of scatter would indicate low strength or weak. Okay, or not very much scatter would indicate strong or high strength. Okay, or another way we can look at it is if we are given one variable, can we predict the other variable? Or how, I should say, how well can we predict the other variable? I apologize. How well okay, and so if we're going to have bad predictions, this will be low strength. Okay, and good predictions, high strength. Okay, so we might have pairs of variables with both with positive trend okay. Okay, so here we have lots of spread. Okay, so this would be weaker. Okay, and over here we have very little spread. So this would be strong. Okay, So, you know, if we were to make predictions for this particular value of x, you know, our predictions would be just kind of in this very, oops, something happened here, very small range of values, okay? Okay, small range for our predictions. But, you know, if this is the x that we're trying to predict here, then the range of values, you know, there's a kind of a much larger range. For our predictions. Okay, so this could be, for this, it could be like, try to guess someone's weight, a person's weight based on their height. Okay, so x could be height, and this could be weight for a person. Okay, and then over here it could be something like, we can look at, maybe we're looking at one particular species of snake. Okay, so one species of snake, and we're going to look at the length of the snake and its weight. Okay, and if they're all kind of the same species, you're going to kind of expect the same level of kind of fatness, and so you know, basically long snakes will weigh more and shorter snakes will weigh less, but we're kind of expecting a very predictable relationship between the length and weight of a snake. Whereas with people, there's kind of there's a wide variety, because you can have short people that weigh little, short people that weigh a lot, tall people that weigh little, tall people that weigh a lot. And, you know, overall, shorter people in general will weigh less than taller people, but at any given height, there's still quite a wide range of weight values, okay? Whereas if we're looking at one particular species of a snake, you know, for a given length of snake, we expect the amount of difference from one snake to another that have like the same length to be there to be very little spread there. Okay, does that make sense? And so, you know, here we're seeing kind of the idea of spread and variation, but now it's for spread and variation for a particular kind of value of x in the other variable. Okay. Okay, so here we've talked about describing whether things have a positive relationship or negative relationship, if it's strong or weak, and if it's linear or not linear, okay? If we have a linear relationship, okay, so for linear relationships, there is a summary statistic. There is basically a numeric summary, or a summary statistic that quantifies the direction and strength of a relationship. Okay, so, you know, in our last lecture we had the standard deviation, and the standard deviation quantified that concept of spread, rather than just saying this data set has low spread, this data set has high spread. We could say this data set has a standard deviation of 1.2, this data set has a standard deviation of 6.5, and we could actually quantify the amount of spread that exists between one data set and another. Okay, So in the same way, instead of just saying this has a positive direction and looks pretty strong, this thing has a negative direction and looks kind of weak, we can actually quantify that and say this has the value, the summary statistic is called the correlation. We can say the correlation of this relationship is this. The correlation of this relationship is this other number. So we can now assign quantities to these things, okay? And so this summary statistic is called the correlation coefficient. Okay, or we might just call it correlation. Okay, and the symbol is the letter R. Okay, like relationship. And so there's the correlation is determined by a slightly complicated correlation, but we're not going to worry about calculating the correlation by hand. Okay, so kind of I'll put down the formula for correlation, but you don't have to learn it. Okay, so the formula for R is equal to the sum product of zx, zy over n minus 1. Okay, but don't worry about this. Okay. Okay, because in truth, no one calculates correlation by hand. Okay, so we almost never calculate correlation by hand. What's important is our ability to interpret correlation, okay? So R can be any value between, so these are key interpretations, okay, or key points for understanding R. R can be any value between -1 and +1 inclusive. Okay, or in other words, -1 is less than or equal to R, which is less than or equal to 1. Okay, so the sign of R indicates the direction of the relationship. Okay, so if R is positive, then the direction of the relationship is positive. And if R is negative, the direction of the relationship is negative. So that's pretty straightforward. Okay, and what does it mean to have a positive relationship? Large X goes with large Y, small x goes with small y, okay? All right, so, well, we can talk some examples here, okay? And then, and the distance that R is from 0 indicates the strength, okay? So I'll just write, if R is far from 0, so what does it mean to be far from 0? So R is close to 1 or close to -1, okay, then the relationship is strong. Okay, and if R is near 0, okay, then the relationship is weak. Okay, so we have kind of a few examples here. So if we have this going on, R is equal to positive 1, okay? Here we have basically no scatter, so that indicates super strong relationship, or perfectly strong. And positive direction. So R here is +1, and this could be height measured in inches, and over here could be height measured in centimeters. Okay, and that, you know, I said another way we could talk about strength is how well can we predict one based on the other. So if I give you someone's height in inches, how well can you predict their height in centimeters? You can get it perfectly right. Okay, all you have to do is multiply by 2.54 or something like that. You just multiply by some number and you'll get the height in centimeters perfectly right. So if you have one variable, you can get the other one perfectly. Okay, and there's a positive trend there. Okay, if we have you know, just a tiny bit of scatter, okay, here this is R would be something like 0.98, okay, and this could be life expectancy. So for men, and we can have life expectancy for women. Okay, so if we looked at across many countries, okay, so one dot for each country, what we will see is that, you know, countries with high life expectancy for their men will have high life expectancy for their women. Okay, countries where the life expectancy is low for the men will have low life expectancy for the women as well. Okay, and you'll find you know, this very strong relationship between these values. Okay, so we've got just a little bit of scatter, positive relationship. Okay, and as the relationships get weaker and weaker, you know, you get more and more spread. And I'm just eyeballing this and guessing, and I'll say, you know, R is 0.5 or something like that. Okay. So we've got, you know, more scatter, but still a positive relationship. Okay, and this continues until you basically get down to no relationship, so neither positive nor negative, something like this. Okay, and so here we would have R equal to 0. Okay, so no relationship, neither positive nor negative. Okay, and then as things start to trend in the other direction, then you're going to get negative R values. So, I'm just making up a number, or I'm just kind of eyeballing this, but I'm going to say, R is negative 0.75 or something like that, okay? So negative trend, negative relationship, some scatter. Okay. And here we have R equal to -1, okay? Negative relationship, no scatter. Okay. A key thing is that these interpretations for R only make sense if the relationship is linear, okay? So the interpretations for R And how do we check if something is linear? We have to make a scatter plot and look at it, okay? So you must make a scatter plot first. You must make a scatter plot to decide if something is linear. So if you didn't make a scatter plot, then you won't know if it's linear. Okay, so either the problem has to say someone else made a scatter plot and it's linear, or maybe it shows you a scatter plot or something. If it doesn't say anything about that, it doesn't mean it's linear. You could have, you can have R equal to 0.95. And it might not necessarily be linear, okay? Because even if you don't have a linear relationship, you can just plug your values into this R formula, and it's going to calculate. It's going to calculate some value here, okay? But you could have R equal to 0.95, but the data could look something like this. Okay, and I think something like this will produce an R value of 0.95, and that's because it's trying to fit kind of, it's as if it were trying to fit a straight line to it and asking, how much scatter is there around this straight line? It's going to say, oh, there's only a little bit of scatter. Overall, R is 0.95 or something like that, okay? This is, it would not be appropriate to use R in this situation. R or correlation in this situation. Okay. Let's just take a quick look. So common mistakes about thinking about R. All right, let's say we have a trend. Okay, what is the R in this trend here? +1, right? Okay. Okay, what is R in this relationship? Also positive 1, okay? So the angle or the slope does not influence r. So r is not influenced by the angle or slope. By the slope or angle, okay? What affects r? Direction and strength, right? Okay, only direction and strength. R tells us direction and strength. And in both of these cases, we have a positive direction and a perfectly strong relationship, okay? And so that's why you're going to have r equal to 1 over here and r equal to 1 over here. The slope does not influence r. Okay. What about this is supposed to be flat, okay? What is this? R is equal to 0, okay? No, neither positive nor negative. Okay, and then as soon as there's just a little bit of a downward angle, you're going to have r equal to -1, okay? And so, you know, r, a lot of times we're accustomed to kind of having like you're imagining some kind of like, I don't know, angle measurement, and it gradually changes from 1 to 1. No, in all of these situations, these are positive, so any angle that's slightly positive, and if there's no scatter, they're all going to have r equal to 1, and then as soon as it becomes flat, r is 0, and then as soon as there's a little bit of a downward trend, then you're going to have -1, okay? The way that to gradually change r, you're going to have to increase the amount of scatter, okay? So either the relationship is either positive or negative or neither. Those are the only options you have for the direction. It's either a positive direction, negative direction, or neither, okay? And then as far as strength goes, you can have weak to strong. And so r only tells us the direction and the strength. So all of these other things, they don't tell us anything about r. Okay, why don't we take a 5-minute break here, okay? We'll come back and we'll talk about applying this for linear regression.